actually will be the first time this semester. Uh-oh. What? The first time this semester that your output's going to depend on two things, not just the input and the current state. What do I mean by that? Just to give you an idea what a state table and state diagrams are, let me do a state diagram. Let's say we're going to design a controller for a coffee machine or a soda machine or a candy bar. I'll make it simple. Your machine only for input uses only nickels. So your input is going to be only nickels, which means what? If the value is equal to 1, that means we put 5 cents. If the value is 0, we have no money. We didn't put any money in it. You're going through your pocket looking for some change there. And let's assume, for the sake of make it simple here, that this candy bar, the cost of it is 15 cents. So your state diagram will look like this. You'll say this is the 0 state, no money in it. That's when the machine is sitting idling there, just spinning. There's a clock that checks to see if there's money or not all the time. And you're going to have an input. If you put no money into that machine, 0 input, the machine should stay at that state. But what happens if you put 5 cents? You should go where? The 5 cent state. So if you put 5 cents, your machine take you to the 5 cent state. If you have the 5 cent state and you put, by the way, if you put 5 cents, do you get any candy? So there is no output, this slash input slash output. There is nothing here. You're not getting a candy, you only put 5 cents. If you put nothing, you don't get a candy either. But what happens if you have the 5 cent state and now you put no money? You run out of money. You have no more money. You stay there and you still don't get any candy. But what happens if you put actually 5 more cents? Then you go where? The 10 cent state. And you don't get a candy either. Still not enough. When you are the 10 cent state now, and you put in 5 cents, what happens when you put in 5 cents? That'll be 15 cents. Is that enough for the candy? Yeah. So the machine now, if you put in 5 cents, it should reset itself. It says, okay, I'm going to give you a candy here. And you're going to change back? No. 0. Nothing. That's it. No change back. I have an eraser here. Where's my eraser? I'll take the. We're not doing any change back here. What happens if you. So now the machine resets itself. We can start with the next person. Or maybe you. Maybe you're still hungry. You want to get another candy bar. You want one for now, one for later. And what happens if you're at this state? So you stay there, right? If you don't put any money there, you stay there and you get no candy. Now what happens if your machine only takes 10 cents instead of 5 cents? The same story, same scenario. So now this is the 0 cent state. If you put no money in it, you stay there and no candy. But if you put 10 cents, what happens? It goes to the 10 cent state. So if you put 10 cents, you go to 10 cents, do you get any candy? No. And what about if you're the 10 cent state, now you put 10 more cents? It goes back to 0. But you're going to get a candy and what else? And 5 cents back. And if you put nothing, you stay here. So notice you actually where you're going to go, it depends on where you are, at what state, and what are you putting in. It depends on the current state and what is your input. And again, this is the first time this semester we're considering the current state. So right now I'm just going to give you different diagrams and says, can you go from this to the state table? So since I have 3 states, I might label, I need actually 2 values. I might label this as state 0, 0. This is state 0, 1. This is state what? 1, 0. And I don't have 1, 1 state here. So if I want to go from state diagram to the state table for this, I have 2 inputs. These are my inputs, which is the current state. I'll call them Q1 and Q0. And also my input, X, how much money am I putting in? If I'm at the state 0, 0, and I put in no money, where's your output, your next state? And what's your output? Do you get a candy here? If I'm doing this example, there is no change back. So if I'm at 0, 0, and I put no money, I stay where? At same place, 0, 0, do you get a candy? No. If I am at 0, 0, and I put 1, 1 means 5 cents. What happens? Where do you go? You go to 0, 1. Do you get a candy? No. If I'm at 0, 1, and I put no money, what happens if I put no money? Stay where you are. You get a candy? No. If I'm at 0, 1 and I put 5 cents, you go state 1, 0. You get a candy? No. If I am at 1, 0 and I put nothing, I stay there and no candy. If I'm at 1, 0 and I put 5 cents in it, where do you go? 0, 0, you reset, and you get a candy. If I'm at 1, 0, not 1, 1. So what about state 1, 1? Because you have, I'm using 2 digits, there's 4 possible outcomes for Q1 and Q0. Could be 0, 0, 0, 1, 1, 0, 1, 1. Now those are unused state. So what do you want to do in this case? That's up to you. You can put a don't care what the machine does, or you can reset the machine. So you know what? If it hits these states, just reset the machine. You know? It's up to you. You can make it don't care. That will make the simplification or the design smaller, easier. But imagine now you got a big guy. You got Ricardo. He wants candy. He's really hungry. He puts 10 cents, and somehow the machine goes to state 1, 1. And it resets itself. He loses money. Well, he's not going to be happy. He's going to be shaking the machine. Well, is it really worth shaking the machine, breaking the machine over 10 cents? So maybe what I want to do in this case is make it go to 0, 0. It's not going to happen that often. And give him that candy bar. So what? How much the candy bar from Costco? 20 cents? He can have it. In the long run, that's going to save me my machine. So I decided here the don't care states, the 1, 1, I'm actually going to, if it finds itself there, it shouldn't really, but if it does happen once a year, whatever the case is, I'm going to reset it and give you a candy bar. I'm sure you're happy, because if you're pushing the machine, putting money, that means you wanted that candy bar. Now you get your candy bar. And now we're going to go and design that. None of the devices we used before we can use here, because none of them use actually the previous state. So we have to look for other devices on the market that takes into consideration the previous states. And that's where you'll see in next class when we talk about flip-flops. That's not the stuff you wear in the summer on your feet. Flip-flop is a device that the output of that depends on the current state, where we are right now, and what's going to happen next. But for today, my goal is how do you go from state table, make sure you understand them, to state diagram, and vice versa. So let me take another state diagram and see if I can generate the state table. I'm going to give you one. We have 4 states here. And this one actually looks funny the way it's drawn here, because we can draw them in different looks there. This is our state diagram, and I want to go and change that to a state table. I'll wait till you finish writing. The way we drew that in this example, the number in the bottom is actually your output. So this is the output. When you're at this state, you get nothing. You get nothing, you get nothing. When you get to this state, you get a 1. So notice how many states do I have? 4. I'm going to need, my truth table should have what? I have 4 states. Let's think about this. And I have 1 input. The input is 0 or 1. 1 input. So I'm going to have how many combinations? I'm actually going to have 8 combinations. Why? State A when the input is 0. State A when the input is 1. State B when the input is 0. State B when the input is 1. State C when the input is 0. C when the input is 1. D when the input is 0. D when the input is 1. So we actually have 8 combinations. So when you do your state table now, I'm going to call these states, I'm going to give them labels. I'm going to label them, I'll call them Q1, Q2. These are the state. State A is going to be labeled as state 0, 0. I'm going to label state B as 0, 1. State C as 1, 0. And state D as 1, 1. So this is the state code. State A is, I'm labeling that as 0, 0. State B, I'm going to call that 0, 1. State C is going to be 1, 0. And state D is going to be 1, 1. So for this state, I'm going to use Q1 and Q0. So here's my state diagram. I'm going to call these the current states. So I have Q1 and Q0. Here I'm going to have my input. I'm going to call that X. And let's see what my output looks like. My output, two things going to happen. What's going to happen, where's my next state is going to be? I should say instead of current state where we are actually. We'll go next state, we'll call it Q1 and Q0 bar. That's the next state, what's going to happen. And also your output, in this case, could be candy, could be soda machine, we'll call it Z. Let's look at the state diagram. If I'm at state 0, 0, and I put in 0 for input, according to my picture, what's going to happen? Stay there. And what's your output? 0. The bottom number is your output. If I'm at state 0, 0, and I put in a 1 here, according to this, you go to where? State B. B is what? 0, 1, and what's your output? 0 again. If I'm at state 0, 1, I put in a 0, that's this one. You put a 0, what happens? You go back to where? A. 0, 0, and your output is 0. But if you put a 1, where do you go? C. And C is what? 1, 0, and your output's still 0. If I'm at state 1, 0 now, that's this one, and I put a 0, according to my diagram, I go back to A. 0, 0, my output is 0. But if I put a 1, where do I go? To 1, 1. Is there an output there? Yes. Now if I'm state 1, 1, and I put 0, what happens at 0? Where do you go? To A, which is 0, 0. Your output is 0. But if you put a 1, you stay there at that state, and you also get an output of 1. So we just went from the state diagram to state table. So that's just one look the way we draw the state diagram. I'll do another one. It could get really ugly, like if you're doing some design. If you want to design a real soda machine, oh my goodness. We'll do a simple one like where you can put 5 cents, 10 cents, and 25 cents. We'll make the soda maybe 25 cents. And you will see that will be like about 40, 50 lines thrown around. We'll wait till the end. Let's take this state diagram. We have state A. Now this one is with the slashes. Always the first number is your input, the second one is your output. If you put a 1 and you go to 0, if I put a 0, you go to A. If I put a 1, I get a 0 here. If I put a 1, you stay there. And if I put a 0, I go back there. Notice we have 3 states and 1 input. These values, it's actually input slash output, the slash there. The first one that you see is your input, the second one is your output. So we have 3 states with 1 input. That means 6 combinations. 3 times 2 is 6. So I'm going to define Q1 and Q0 are my state. So the I'm going to call it what? 0, 0. Maybe I'll call the B 0, 1, and this is 1, 0. I'm not using the 1, 1. So that stays out. This is the current state. My input, I'm going to use X for input. And again, just like before, and now let's figure out what's going to happen next. What is my next state? Q1, Q0, we'll use the bar for them, that's the next state. And your output, I'll use Z again. So when I give the state table now, I'm going to go state A, which is what? 0, 0. And I put in nothing. According to this, what happens? You stay there and you get nothing. If I'm a 0, 0 and I put in a 1 here, 1, it looks like you go to B and you get nothing. B is 0, 1 and you get nothing. If we are to state B, which is 0, 1, and you put a 0, you go back to A, which is 0, 0, and you get a nothing. If I'm at state 0, 1, and I put a 1 there, I go to where? C. And my output is nothing. Notice my output is 0, nothing. If I am a state 1, 0, that's C here, and you put 0 in it, you go back to 0, 0, your output is 0. If I'm at state 1, 0, and I put a 1, I stay there, output is 1. And the state 1, 1 and 1, 1, I really can't answer that because it doesn't say anything about them. It could be don't care, it could be anything. I'm not the designer of this. If somebody said design this, then I can decide on that. So these two I'm not using here because there's nothing mentioned here about what will happen if we hit state 1, 1. So that's how we go from state table to state diagram. And I can go the reverse. I can go from this to this, actually. I can give you 1. Like I could give you the reverse of that. I'll make 1 up. Oh. Let me do a reverse one. This is the current state, Q1, Q0, current. This is X, the input. This is the next state. And this is your output. I'm going to make something up, gibberish. Then we'll look and see what the state diagram looks like. Zero, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. And let's decide to make this one, now the next state, I don't know, 0, 0, 1, 1, 1, 0, 0, 1, 0, 0, 1, 0, 1, 1, and 1, 1. And let me make 0, 0, 1, 1, 0, 1, 0, 0, 1. I just made something up. Given this state table, can you go from here and give me the state diagram? I have 4 states. These two are state A, 0, 1, that's B, 1, 0, that's C, and 1, 1, that's D. Here we go. This is state A, state B, state C, state D. A 0, 0. If my input is 0, you stay there. And what's your output? 0. You stay there. If your input is 0, you stay there, your output is 0. But if I'm at 0, 0 and I put a 1, you go to where? 1, 1. 1, 1 is where? D. And what's my output? 1. If I'm at state 0, 1, that's B for both of these, and I put a 0, I go where? 1, 0. My output is 1. See it right there? This we get to see them. And what about if I'm at 0, 1, I put a 1? Where do you go? Stay there, and what's your output? 0. So if you put a 1, you stay there, your output is 0. Looks like parallel lines so far. Let's see what happens next. If I'm at 1, 0, that's state C, and I put a 0, I go where? And you get a 1. If I'm at 1, 0 and I put a 1, what happens? Stay there. Your output is 0. And the last one, if I'm at 1, 1, I put a 0. I stay there. My output is 0. And if I'm at 1, 1, I put a 1, guess what happens? Stay there. And my output is 1. So that's going from the state table to the state diagram. We should be able to go back and forth between them. And again, I need a device that will take into consideration my next state, and my output is going to depend on the current state and the input. Not just the input and where I was when that happened. And that will take us to the next topic, which is latches and flip-flops. And we have lots of flip-flops to look at. I'll just show a quick picture of latches there, or a flip-flop. A latch is a binary storage device. It says composed of 2 or more gates with feedback. The word feedback means your output depends on the input. We take it and we give it to the output. Notice your output is fed back into this. This is actually an SR flip-flop. If you look at it, you try to find out what P and Q are, you'll see what the value. This is an OR gate with the NOT, that's an OR gate. So P actually depends on the value of S and the value of R. You ignore them together. And Q here, notice if this is S here, this is Q. Can you see that? So P actually is the value of S or with Q and with the NOT, the complement over it. I don't know if you can see that little knot. And if this is P, this is really P here. This is Q. Q here depends on P and R. So P plus R, that's an OR, and you knot them there. And that's what that knot here that you see there, in case you can't see it. So notice how your output depends on the output from here and the input, and this output here depends on that output plus the input, which means you don't want to do that till we get the result here. So we're going to start thinking about delays, time-wise. Our book might do a picture like that to show you. You really want to slow down a little bit there so that signal makes it there. If you're going too fast, you will miss it. See that little delay there? Can you see that dotted line? Because if this one starts to go, oh, let me look at the value now. Well, it's too late. So you got to wait a little bit till that signal makes it here, and this one changes, then you start reading that value. So we call these actually flip-flops, and we have lots of them. We have T flip-flop, JK flip-flop, SR flip-flop, master state flip-flop, D flip-flop, T flip-flops. We're going to be looking at all of them in the next video.